In this example, we're going to be using a binomial probability distribution. And the reason we're using binomial is because the number of observations is fixed. I believe here it says 16 in this particular case. We also see that each observation has one of two outcomes. It's either a success or a failure. They either sneeze or they don't sneeze. We also can safely assume that sneezing is independent, so that, in other words, what one person does should not be affecting what the other person does. And last but not least, the probability of success of sneezing stays the same for each observation, which we're given that probability here. So once we know that we've checked all those boxes for binomial probability distribution, we can use that feature inside of our calculator. So we're going to do that to find the probability that among 16 individuals, exactly 17 do not cover their mouth when they sneeze. The probability that among 16, fewer than 6 cover their mouth when they sneeze. And then we're going to see if we would be surprised or not if fewer than half cover their mouth when they sneeze. Okay, keeping in mind again that the probability a randomly selected individual will not cover his or her mouth when sneezing is 0.267. So to find these, the binomial functions inside the calculator, we're going to use second vars, and we're looking for binomial either PDF or CDF. So you do have to scroll down. And what's going to determine the difference between these two is, are we looking at exactly one observation? If we are, we use binomial PDF. Or are we looking at multiple observations, like 6 or fewer, like in this case, or cases, I guess we could say? Then we would do binomial CDF. That's a cumulative density function. So it's adding up several different possibilities. So again, for part A, we're going to do PDF because we're looking at exactly one particular case. In this case, exactly 7 do not cover their mouth when sneezing. So first of all, we give the calculator the information it needs, which is 16 trials. The probability of success in this case is not covering your mouth when you sneeze, and the exact X value is 7. We'll paste that, and we get this probability, which we're asked to round to 4 decimal places here. The next one, since it's asking for fewer than 6 do not cover their mouth when sneezing, we'll come back to second vars, that's the distribution menu. We'll scroll down to binomial CDF. We'll give it the number of trials, 16. The probability of success, which is 0.267. And we want fewer than 6. Okay, so this should be 5 or less. And by default, our calculator here is looking at the less than case. So that matches up perfectly with what we have in our calculator. So fewer than 6 should be this value. For this last question, the wording's kind of changed up a little bit. So it says fewer than half of 16 individuals. First of all, half of 16 would be 8. When we go to our calculator, fewer than 8, we're going to type in X is 7. But the wording I'm referring to that's changed up is now they're covering their mouth. The probability that we were given is that the individual will not cover their mouth when they sneeze. And we've got this value up here. So there's a couple of ways we could look at that. And I think I'm going to take what I would consider the simplest way And I'm going to change my probability of success to be interpreted as they cover their mouth. So if I find 1 minus 0.267, this is the probability that they cover their mouth, 0.733. And I'm going to use that probability with this information now in binomial CDF. So I'm going to come back to binomial CDF. I'm changing my probability to 0.733. Fewer than half means fewer than 8, which is the same thing as exactly 7 or less. So that would be what I want for my x value. And I get this result. So this probability, I know I'm kind of going out of order here, but I do need that probability first before I can finish this statement. That probability is less than 0.05, which makes it unusual. So the probability that they cover their mouth, fewer than half cover their mouth, would be surprising because that is an unusual event.